And today's topic, we have totally two parts. One is hardware. This one you can see, this is a new hardware. We call it NBS 7000 series switches. And about the technology, we will talk some things, a new feature we call it virtual cluster switching. So this is today's two main parts, only focus on special products and some special technology. Before we talk about the detail, I want to have a brief introduction about myself. My name is Emily, and here is my email. If you have any suggestions about the radio products or maybe radio technology, you also can send this information to my email. I will reply as soon as possible, as much as possible. And I'm the trainer of the regional technical team in the Radio International, and I have training over 7 years, focus on the security like the firewall, routing and switch, wireless, and exactly. And maybe in the future also talk some technology about the data center. So this is myself. And about this part, about the training topic, we say we have two parts. One is hardware and another one is technology. And let's say why we choose this topic. And what's the scenario we can use if you use this technology? For example, I will show you one typical topology. And in the network, you can divide your LAN. LAN means your local area network. Of course, in our own network, you also have some public network like the internet. Now we only focus on the special scenario, a special network. Maybe you maintain with your customer, or maybe you're also the employee in your company, you have to maintain your network. You can divide your network to be several layers. One by one, the last layer is a terminal. Maybe you already use your PC, your personal computer to connect with our network. Then you want to get some resources. Of course, you also can connect some wireless device like the AP, or maybe some your phone to connect our internet. So this layer we call is a terminal. And about this terminal, usually will send out some message and need our network devices to help us forward the message out. And the upper layer is access switch. Usually about the access switch, we can provide some basic and easy protocol like the VLAN, like the FTP, something like this. And upper, we will use a distributed switch. About this layer switch, the performance is higher than the access switch. And also maybe we can provide more resources like the ports number, right? And also maybe a little complex technology we can deploy on the distributed switch. Of course, about the distribution switch, we also maybe provide some layer 3 function like the IP route, static route, something like this. And the upper layer, we maybe deploy the core switch. And the core switch performance also will be higher than the distributed switch. Then we can use the core switch to wait lots of different IP segments, something like this. Then we will use our router or maybe radio EG to wait the internet. And in this topology network, you can usually see different layer what's a typical function. Of course, based on your network size, maybe your network size is small, only have terminal access and directed to connect with router. It's okay. Maybe your network is very big. In each layer, not only 2 switches, maybe over 40 switches, or maybe you have lots of routers to create different internets, something like this. But totally, we still can divide them to be several parts, like this one. Okay, so this is the typical topology. And about this topology, I have one question. In our training, I will provide some questions. If you have some answer, you can reply to me. If one link or maybe one device is broken, for example, here, if this link is broken, or maybe this switch is broken. What's the result? If you have lots of terminals like this topology located in different access switch, can they communicate with each other? Yeah, I already get some answer. In this topology, if the link or maybe the device is broken, these terminals located in different access switch, they cannot communicate with each other, right? And about this phenomenon we call is single failure. So if your network, especially some very important network, we hope we can avoid this single failure. Our good network is if one link is broken, can we provide the second path? If one device is broken, can we provide the second device? If the other backup path is located, we still can use the second path to force the message out, right? So this is a good network we hope we can maintain in our network. So this is the disadvantage if you in your network between all the terminal or maybe all the devices, if you only have one path, there is a single failure. And if you want to provide some backup technology, you have to provide some physical backup link. This is the first step. And the second step, you have to deploy some special backup protocols, right? So now my question is, what technology do you know about the HA, high availability? So if you have any idea, you can write down on the chat window. Let me see what's other technologies you want to know. About the HA, only the special feature of the high availability. Redundant. Actually, this is a function we hope we can get the redundancy failover VSU technology or VSX on the special layer 2 and layer 3 redundancy VRP. Oh yes, I get lots of stacking in the core switch. Yeah, good. SVU, I guess you want to write down VSU. Okay. No more? Only VSU? Cluster, FHRP? Whoa. Okay, I think I already get a lot of, yeah, we also can do STP because about the STP, maybe someone thinks this is not high enough, but about the STP, we also can provide a backup link. So we, if one link is broken, we still can choose a second path, but maybe the time is a little long. So someone maybe think this is not high enough, but this one also is ability protocol about the STP. So I already get some voice about the technology, how to provide the high availability, because only focus on the technology. We have lots of technology we can use. So of course, in different layer, we will choose different protocols. Someone maybe say later we will talk about the detail is a VCS. Is this one is very similar like the VSU. But not every link we will choose a VSU, or maybe we call it VCS. But the special one, for example, about the core switch and the router, between the core switch and the router, maybe we will choose the routing backup. For example, you can use some dynamic routing protocol, and if one link is broken, we can calculate by the protocol automatically. So this is a layer 3. But about the access switch, maybe the performance is not so enough. So we only provide the STP is enough, because the performance is not very well. So differently, maybe we will choose different technology. And how to work about like the basic of the STP, or maybe dynamic like the OSPF, how to work and how to meet the requirement of the high available. And about this part, we already explained on our RCNA, and in the future on the RCNP course, we will talk the detail. But today we will choose a special technology, is very similar like the VSU, but we deploy on our relay switch. This feature we call is VCS. So about the service requirement, if we only focus on the core switch layer, we hope we can use one technology. Some feature we hope this technology can have. The first is we can reduce the failover time. If one link is broken, how to find the broken time as soon as possible. Then how to use the backup path as soon as possible. So these are two features we are very interesting. And also we hope we can provide some high resources usage, right? For example, if we provide a lot of links to connect with each other, we hope every link and every device can help us force a message out. So the resources can be used all the time. So about this feature, maybe some scenario, especially on the core switch, we don't want to use STP. And also we can provide some extensibility of the device's port. For example, if the port is not enough, we can increase the port as much as possible. And also we can provide some simple management and also the network topology. These features, we also, all of the features we want to have in the core switch. So this is a requirement. And in order to meet the requirement, first you have to make your topology more stronger. For example, about this one, you can add a more link. For example, here, between the core switch and the distribute switch and the core switch, between them, you can provide more links to connect with each other. Then you can use a special technology we call it VCS, virtual cluster switching. Then if you use this switch, we can make two switches like the logical one switch. It's very easy to do management, and it's very easy to help us to provide some configuration, something like this. And if we use this technology, we can provide this active status. All of them can help us force a message at the same time. Then between them, how to detect the link is ready or not, or maybe how to detect your pair, your device is working or not. We have to use special link. About this link, we call it VCL, virtual cluster link. And about the distribute switch, you also can use some aggregation link, aggregate port. Then we can connect with all the switches, and there is a no loop. So it also can provide the resources, how to use the management. All the link can help us for the message. So this is a basic technology we will explain today. And about the VCS network, this is the main part. Later we will explain how to work about the VCS and how to do the configuration. And here also some limitation, maybe you deploy the VCS. Before you deploy the VCS, you must know it. And about the VCS, the full name is virtual cluster switching. Currently, we support 2 switches connect with each other. Maybe in the future, we can add more switches. If you deploy the VCS in your network, and there are lots of advanced you maybe can get. First is it's very simple to do the management. Very simple to do the management, because if you use the technology to mix them together to be a logical switch, then you can direct it to do the configuration, and all the configuration will be synchronized from the active to the standby. And also use the same web page, you can direct it to visit the second member switch. So this is the first advance. The second one advance is you can simplify your network topology, because in the logical, these two switches are one switch. So there is no loop. We no need to deploy the STP or maybe ISTP or maybe MSTP again in order to avoid the loop, right? So this also is an advantage. And another one is, first is if you use this technology, we want to make your network more easy and more easy to do configuration, more easier to do the management. And another one is the basic feature. If we get some active or maybe active link or maybe active device is broken, we can detect the failure as soon as possible. And about the VCS, how to detect the failure and how to do the switch over. The time is 50 to 500 milliseconds. So it will be very fast. And also between them, you can provide some link, we call it VCL. And the VCL, you also can use some aggregate link. And between the core switch and the distribute switch, if you use a VCS to make two switches to become one, then you can use a great link to make all the link can work at the same time. So these are the advantage if you deploy the VCS in your network. So later we will explain the detail one by one, how to work and what's the main feature we have to consider when we deploy the VCS. And another one is you must know which device can support the feature. Pay attention, not all RAE switches can support the feature. So today we will explain 7 series switch and how to do the configuration and what's the main principle if you want to use this feature in our network. But before we talk about the principle, let's see the hardware. And about the hardware part, we will have another trainer, my colleague Eureka, to explain us about the hardware part. Of course, same, if you have any question, you can write down on the chat window and I will reply with you.
Okay, can you hear me?
Yes.
Okay. Hello guys, I'm Eureka, and next I will briefly introduce the hardware composition of the MBS 7000 series. Firstly, the MBS 7006 model. Does anyone know the meaning of the name MBS 7006? What is MBS and what 7006 means? Actually, the full name of MBS is New Business Switch, and the first number represents the capacity of the switch, where the number 7 represents this switch is capable to be used as a core switch in the network. Other numbers like 5 to 6, okay. Other numbers like 5 to 6 represent that the switch can be used as an aggregation switch. The number smaller than 4 represents the access switch. So the larger the number, the stronger the performance of this device. And the 3 following 0 is used by default. That's the meaning of 7000. And the last number 6 represent that the switch has 6 line card slots. Next, that's the basic hardware components of MBS 7006. It consists of a chassis, system modules, power supply system, and heat dissipation system. First of all, let's take a look at the chassis. We can see 3 main parts of the front panel of 7006. The supervisor engine slot, line card slot, and cable management frame. As for the back panel, there are power supply module, fan module, It's not clear. Hold on a minute. What about now? Okay, then I will continue. So for the back panel, there are power supply module, fan module handle, and captive screw and a nameplate. And we will talk about the details for these three main parts. Let's start with some basic specifications. 7006 can accommodate 2 supervisor engines and 6 line cards. The 2 line card slots can be used for management. That means 7006 supports 1+1 redundancy. It can improve the overall performance of the switch. Different line cards carries different types and quantities of interfaces, which can support specific sub-functions. By selecting different type line cards and assembling them into a whole, users can meet their requirements in different scenarios. You can see 8 of the models. 1 is used as supervisor engine and the 7 are used as line cards. As for the heat dissipation system, fan modules and the power supply modules both support hot swapping, while the line cards do not. Then let's see the line cards can be used for 7000 series. The first one, M7024GT 2XSEA, the letters and numbers actually have their specific meanings. The name of this line card indicates that it can provide 24 GB electrical port and 2 10 GB optical ports. You can see the following parameters as a reference. T means 100 Mbps electrical port. GT means Gigabit electrical port. SFP means Gigabit optical ports. And XT, XS, they all have different meanings. So let's take this one as an example. The name of this line card indicates that it can provide 24 Gigabit electrical port and 24 Gigabit optical ports, 2 10 Gigabit optical ports. So these 8 line cards in the pictures are universal for the 7000 series, but please pay attention to this one, M7006CM. It shows here that it could only be used for 7006, but why? Here is a small tip for you. M7006CM is a supervisor engine, and other 7 ones are all line cards. So let's see the following content first. The power supply system consists of 4 system power slots, supporting 1+1 and 2+2 power redundancy. However, it should be noted that the power module must be the same. We recommend redundant configuration of the power supply to reduce the risk of power failure. The power supply system and the fan system together ensure the service ability of 7006. So that's all for this model. We know that it has 2 supervisor engine slots, right? But I have one question. Can 7006 work properly without inserting supervisor engines? Does anyone know the answer?
I guess no.
Okay, then yes, it's no, because the management model in 7006 is independent and other line cards don't support management function. So at least 1 supervisor engine is necessary. So let's move on. Next, the other model of MBS 7000 series, 7003. The hardware system component is similar to 7006. We can learn from the model name that there are only 3 line card slots in the 7003. It has a reset button, management port to control the line cards uniformly. This is different from 7006 because it doesn't have any supervisor engine slots as 7006 does. You can see in the specification table, it can generally store 3 line cards. You can use 1 line card as a supervisor engine in slot 1, but its capacity will not be the same as supervisor engine. At the same time, it should be noted that the first line card slot of 7003 must have 1 line card in position, so it can operate normally. These limitations makes 7003 inferior to 7006. You can see the line card used for 7003 in this video. They are the same with what we have just seen in the 7006, right? Except the M7006CM, we cannot find it in this video because this is a supervisor engine and 7003 doesn't have supervisor engine slot at all. In terms of the similar components, there is another thing you should know that for the power supply system, 7003 only support 1+1 redundancy, which is different from 7006. Besides the main differences we've just introduced, you can refer to the detailed comparison parameter to get more info of 7000 series. Here in this figure, the number of SFP, the switching capacity, the forwarding rates, and so many parameters are different. You can search for the installation guide of the MBS 7000 series on our official website, or if you have filled in the training registration form, we will also send it to you together with the training material. So that's all for the hardware part. Thank you.
Thank you so much, Ulrich. And do you have any question about this part?
Yes, hello. I have a question about the NBS series.
Yes.
Yes. Okay. So this is the NBS 7000 series. So how about the NBS 5K series? MBS 5K series support stacking, right?
Which one? Which series device?
NBS 5200 series.
5200, yes.
Is in the support the VCS, means the stacking technology.
Stop today, only 7000 can support. But in the future, we also have the planning support. I remember maybe the next series is 6000. In the next planning, I have to check with our colleagues. But only support today, only the 7000 can support.
Okay. Okay, thank you for information. Thank you.
Yes. Power supply server for all equipment chassis. Yes, depends on how many LAN cards you want to use on your chassis. About the 7006. If you use 3 or less LAN cards, maybe you have to use a power 1+1, one for the active and another one for the backup. If over 3 LAN cards, you have to use 2+2. Yeah.
Okay, I want to double confirm one question, please. Double confirm the information. For the model MDS 700 I saw the hot swappable only for the power supply and the fans, but for the line card is not the hot swappable, correct?
You mean which device? MBS.
NDA 7003. The line card is not
003.
hot swappable. Yes, the line card is not hot swappable.
Yes.
Okay, for 7006, same also, not hot swappable, or it's hot swappable. I can change the line.
Change the line. You mean, for example, line 1 in the slot 1 and change to slot 2, right?
Yes.
About the line card, we cannot support the hot swap, but about your management card on the NBS 7006, it can support.
Can be supported.
Only
Okay.
the management card, not about the LAN card.
Okay, thank you.
Yes. I guess about the recording video and the material, we also will add the hardware installation guide to you. Because about this hardware part, we only talk some important part to you, how many line and how many line cards you can use if you buy the NBS switches, and what's the different LAN card number in these two devices. But about the detail, for example, someone asks the power and also which card can support the hot swap. All the information on the installation guide, we can provide the detailed explanation for you. So about these two documents, we also will in the training material sent to your personal email.